Welcome to Chapter 6. Frame the chapter in one line. 2 HTML element families, each built for a specific job. Tables for displaying organized data, forms for collecting data from the user. Both are tag families students will use constantly going forward. Every dashboard, every sign-up page, and every pricing grid relies on one or the other. Quick recap of the arc so far before diving in. Chapters 3 to 4 gave structure and styling. Chapter 5 made pages respond to the device viewing them, and this chapter adds 2 new tag families with specific jobs. Tables display organized data, forms collected back from the user. Part divider for tables. Use the annotated table graphic to preview the 4 tags coming up next: table, tr, th, td, without teaching them yet. The test for when data belongs in a table, worth having students repeat back. If you'd naturally sketch it on graph paper, it's probably a table. Walk the 3 example categories: class schedule, price comparison, sports standings, as concrete cases where position in the grid carries real meaning. Land the negative case hard, since it's the most common student mistake. Never use a table for page layout that died with 2005-era web design, and Flexbox and Grid from Chapter 3 do that job now. The quick rule at the bottom is worth reading verbatim. If the information is data and the position matters, use a table. If it's just for layout or styling, use CSS. The 4 foundational tags. Table wraps the whole thing. TR is one table row. TH is a header cell. Bold and centered by default, and worth flagging that screen readers also read it aloud differently than a regular cell, which sets up why using the real tag matters later in the chapter. TD is a standard data cell. Walk the code to rendered table rows on this slide slowly, since this is the first real table markup students are seeing. 3 grouping tags that add structure on top of the 4 basics. Thead holds the header rows, and repeats if a table spans printed pages. tbody holds the actual data rows. Every table should have one. tfoot holds totals, or summary rows, like a receipts total line. Land the key framing point. These 3 are purely structural. Browsers don't require them to render a table correctly, but screen readers and CSS targeting both benefit from having them present. This is flagged directly in the textbook narrative as the single most skipped accessibility detail in student table code, so give it real time. Scope equals curl means a header describes everything below it in that column. Scope equals row means a header describes everything to the right in that row. Without scope, a screen reader user can't reliably tell which header goes with which cell once a table gets more complex than a simple grid. Walk the diagram's bottom callout directly. A screen reader announces, Alex, score, 92 inches. Scope is what makes that correct association possible. 2 merging attributes. Colspan equals 2 makes one cell stretch across 2 columns, common for a section title spanning a wide table. Rowspan equals 2 makes one cell stretch down across 2 rows, useful when one label applies to several rows beneath it, like a shared day/time value in a schedule. Land the shared gotcha for both, since it's the most common bug. The merged cell counts as multiple columns or rows, so don't add extra TD tags for the space it covers. Walk the 2 columns total and 3 columns total callouts on this slide to make that concrete. This is the worked example combining thead/tbody/tfoot structure with both colspan and rowspan in one realistic table, a weekly schedule and pricing grid. Walk it as a real planning exercise. Rowspan equals 2 lets mon-wed cover 2 class times without repeating. Colspan equals 2 lets courses and pricing each span 2 subcolumns. Colspan equals 6 lets the note row span the full width. Land the practical advice directly. Plan merges on paper first, counting columns and rows carefully before writing markup. The common bug is forgetting that a span cell changes how many TD tags the rest of that row actually needs. Table border cleanup. By default, every cell gets its own border, which doubles up into messy double lines everywhere. Border collapse. Collapse merges adjacent borders into single clean lines. Almost every real-world table uses this. Border spacing is the alternative for when collapse is not used. It controls the gap between cells instead. Point at the before/after tables directly, since the visual difference is more convincing than the CSS alone. Zebra striping, alternating row background colors, makes wide tables far easier to scan, done with pure CSS and no JavaScript needed. tbody (tnth child) even targets every second row. Walk the what's happening note at the bottom. Nth child looks at each row in order, even matches rows 2, 4, 6, and odd matches rows 1, 3, 5. Land the usability note. Keep the contrast subtle. The stripe is a scanning guide, not something meant to draw attention to itself. Row hover feedback, TR. Hover highlights whichever row the cursor is currently over, a small detail with a real usability payoff on dense tables. Point out the 2-rule pattern. One rule sets a transition on all table rows for a smooth fade. The second rule changes the background color specifically on hover. Pairing them avoids an instant, jarring color snap. 4 common table mistakes. worth walking each with its bad/better comparison. Tables for layout. Positioning a logo next to a nav bar with a table is a Flexbox/Grid job now, not a table job. Missing th. Every header row needs the real th tag, not a bolded td. Screen readers rely on the actual tag, not just how it looks. No scope attribute. Visually obvious header relationships are invisible to assistive tech without it. Discounted spans. A colspan or rowspan that doesn't match the actual grid breaks the whole table's structure, which is why planning merges on paper first matters. Part divider into forms. A form's job stated simply: collect structured input, then hand it off somewhere. 4 form categories students will recognize instantly: login, username plus password; contact, name, email, message; checkout, address, payment info; and search, a single query field. Land the important scoping note for this chapter directly. Right now, that somewhere the data goes is conceptual. Real submission to a server comes with PHP in a later chapter, so today is entirely about building the front-end collection mechanism correctly. The form element itself has 2 required attributes to know. Action is where the data would be sent, a URL or script. Method is how it's sent. Get puts data visibly in the URL, fine for something like a search query. Post hides it in the request body, used for sensitive or large data. Be explicit with students about the honest scope here. They'll write action and method correctly starting today, but nothing will actually receive that data yet. That's PHP's job, coming soon in Chapter 7. This is bonus material beyond the core textbook narrative, worth flagging as such. Field set and legend. Field set draws a box around a related group of inputs. The browser renders that border for free, no CSS needed. Legend labels that group, sitting right on the border line itself. Practical use. Breaking a long form into labeled sections like your details and preferences makes it easier to scan and style. No extra required attributes, just wrap the inputs that belong together. Land this heading exactly as titled, a pairing, not a suggestion. Label tells the user, and assistive tech, what an input is for. Connect them with for equals on the label matching id, equals on the input. The usability payoff worth demonstrating live if possible. Clicking the label text itself focuses the input, not just the input box. A small detail students will forget to implement if they don't see it demonstrated. A tour of 8 distinct input types beyond plain text. Walk this as a reference table rather than teaching each one individually. Text for free-form short text. Email, which validates the @ format. Password, which masks characters. Search, which adds a clear icon. Telephone for phone numbers. Date for a native date picker. Number with steppers. And URL, which validates URL format. Land the mobile-specific payoff directly. Each type triggers a different on-screen keyboard on mobile, so type choice matters even before any validation logic runs. 4 ways to go beyond a single line input. Text area for resizable multi-line text. Select plus option for a drop-down of fixed choices. Checkbox inputs for picking any number of options. Radio inputs for picking exactly one from a group. And the detail worth emphasizing since it trips students up. Radios must share the same name attribute to actually behave as one group. If the names differ, multiple radios can end up selected at once, which defeats the purpose. 3 buttons that look identical but behave completely differently. Worth demonstrating this distinction concretely, since it's a common source of bugs. Submit is the default type inside a form, and triggers the form's action/method behavior. Button does nothing on its own, used specifically when JavaScript should handle the click instead, which sets up the JavaScript section later in the chapter. Reset clears all form fields back to their defaults. Flag it as rare in modern forms, and easy for a user to trigger by accident, so it's usually best avoided unless there's a specific reason to include it. The required attribute, the simplest form of HTML5 validation. Adding required blocks form submission until that field has a value, and the browser shows its own built-in error message with 0 JavaScript needed. It works across many input types, text inputs, checkboxes, selects, and more, not just plain text fields. More specific HTML5 validation beyond required. Type equals email, automatically checks for a valid @domain.tld shape. Pattern accepts a regular expression for custom formats. The slide's course code example, A to Z 40 to 94, is worth walking character by character, since regex syntax is new. Min/max constraint number and date inputs to an acceptable range. Land the big picture point. All of this happens before any JavaScript runs at all. It's free validation straight from the browser. 3 CSS techniques for making forms pleasant rather than merely functional. Focus visually highlights whichever field is currently active. Walk the 3-state comparison, default, focus, and valid, on this slide directly, since seeing all 3 side by side makes the visual feedback obvious. Consistent padding and spacing between fields reduces misclicks. And a genuinely important UX point worth emphasizing. Style the browser's invalid state sparingly. Don't visually shame the user with red borders before they've even finished typing into a field. This is a direct, explicit callback to Chapter 5's hamburger menu JavaScript. Worth naming that connection out loud, since it's the same underlying pattern applied to a new job. Chapter 5. Click right pointing arrow React, add event listener. Click. On the hamburger icon, toggle the mobile nav. Chapter 6. Submit right pointing arrow React, add event listener. Submit. On the form checks fields, before letting it proceed. Land the takeaway directly. Same event listener pattern, different event, different job. Students already know the shape of this code from 2 chapters ago. The actual submit catching code, matching the textbook narratives example exactly. 3 steps. Listen for the submit event with add event listener. Submit. Stop the default behavior with prevent default, so the browser doesn't submit before your code finishes checking. Then validate before proceeding. If validation fails, show a message and return early so the form doesn't proceed. Walk the password length example in the code panel directly, since it's the exact pattern students will extend in assignment 2. Close the forms section by being explicit about the current scope, since students may otherwise wonder if their work today is complete or broken. Right now, the forms action points to a file that doesn't exist yet, and that's fine. Method equals post packages the field data and sends it toward that action URL, but nothing is listening on the other end yet. A future chapter introduces PHP, which will actually receive that data, process it, and respond. Land the takeaway. Today students are building the front end that PHP will plug into next. This is the full chapter recap graphic. Use it to tie tables and forms together side by side, rather than introducing new material. Left half recaps tables. The graph paper test, never using tables for layout, the scope attribute for accessibility, and the 3 structural tag groups, table, thead/tbody/tfoot, colspan/rowspan. Right half recaps forms, the label input pairing, get versus post, built-in browser validation, and a few common input types with their best use cases. This chapter has 3 assignments rather than the usual 2, so be explicit about that shift. Assignment 1. Build a table. Practice head/tbody/tfoot and scope. Use at least 1 colspan or rowspan merge and style it with CSS, borders, zebra striping, hover. Assignment 2. Build a form. Practice label plus input pairing. Use field sets/legends to group related fields, use a mix of input types, validate with HTML5 attributes, and style it to look intentional rather than default browser styling. Assignment 3 is the live site capstone. Add a styled table somewhere on their real site and build an actual contact page using a field set-based form, their own take on the reference design shown in class, not a direct copy. Closing transition slide into Chapter 7, bringing your forms to life with PHP. Use it to set expectations directly. Everything built today, the form's action, method, and structure, has been getting ready for this next step, where PHP will finally be the thing on the other end, actually receiving and processing that submitted data.